Hello, we're going to do section 2.4 today. Average rate of change of a function. Okay, so we're going to look at an arbitrary picture of a graph. Okay, this is the x-axis. This is the y-axis. This is our f of x. Now, how do we know it's a function first? We know it's a function because vertical lines indicate x equals, right? A vertical line is x equals. And to be a function for every x, there's one and only one y. So you can see where each of these vertical lines that we're drawing are touching the function only in one spot. So for that x, there's one y. For that x, there's one y. So we know that it's a function. Now, we also, on this, want to know the rate of change, average rate of change. Okay, so we're going to have 2 points, f of a, and we're going to have f of b. F of a is a point on the function, and f of b is a point on the function. So that means that a is down here, and b is over here. So function of a is this dot up from a, and function of b is this dot up from b. Now we're going to take a line, and we're going to draw a line between those two functions. So average rate of change says from this point to this point, it does how much change. We're taking that line, and basically all we're doing is finding the slope. Now we all know how to find the slope of a point, of a line. So we're going to look at the function. The average rate of change is like the slope between those 2 points. So we're going to have the 2 points first. So what is the name of this point going to be? Well, we go out a and up f of a. So the point's going to be a, comma, f of a. And this one's going to be b, comma, f of b. So we're taking the difference in the y's over the difference in the x's to find the slope of this line. So we're calling that now the average rate of change. Because we don't have a line, we have a curve that's going to have a lot of different rates of change on the function. So the formula for average rate of change then would be difference between the y's. So we're going to start out with f of b minus f of a over b minus a. So it's like saying y sub 2 minus y sub 1 over x sub 2 minus x sub 1, because the a and the b are the x's, and the f of a and f of b are like the y's. So this is the average rate of change. Now we're also going to talk about the net change. So the net change is just the numerator, f of b minus f of a. So we still have to find f of b and f of a, but then subtract those two things. All right, so we're going to look at an example. So we're going to be given a function, f of x equals x minus 3 squared. And we're trying to find the net change and the average rate of change between x equals 1 and x equals 3. So the first thing we're going to do is we're going to find the f of 1, using this as my function, right? So I get f of 1 means that I place 1 in for x. So I get 1 minus 3 squared. So 1 minus 3 gives me a negative 2. Squared then would be a positive 4. So the next one we have to put in is 3. So f of 3 equals parentheses 3 minus 3 squared. 3 minus 3 is 0, so that's going to give us 0. So the net change is going to be the f of 3 minus the f of 1. Okay? Because we do f of b first. And we get this one's going to be 0. And this one's going to be 4. So 0 minus 4 is negative 4. That's the net change. We're just taking the numerator part for net change. So the average rate of change then is going to be the f of b minus f of a over b minus a. So f of b is my 0, minus this f of a is minus 4, and then I have my 3 minus 1 in the bottom, my b and a. So I get negative 4 over 2, which comes out to be negative 2. So this one would be called my average rate of change. Okay, we're going to give everybody a chance to get caught up to that point first. Okay. Next thing we're going to look at is an example that has an application to it. This one's in the book if you want to look it up. Example number 2, page 185. Okay, so we have a situation of dropping an object off of a tall cliff. The distance it's fallen is d of t equals 16t squared. It says find the average speed or the average rate of change. So we're looking for the average rate of change between 1 second and 5 seconds. So x, or t in this case, 1 second, and t is 5 seconds. Okay? Now, what do we have to do with the 1 and the 5? We have to plug them in, but first thing we're going to do is we're going to write it out. So the distance over time. Now, we got that distance over time. We're looking for the speed of something. Well, the average speed is the rate. So we have the formula distance equals rate times time. So if I'm looking for rate, I would divide by t on both sides and get d over t. So that's what we're looking at, distance over time. So we're going to have d of 5 minus d of 1 over 5 minus 1. So we're going to find out d of 5 now by plugging 5 in. So I get 16 times 5 squared minus, plugging in 1 gives me 16 times 1 squared all over 5 minus 1, which is 4. So now if you use your calculator, 16 times 25 gives me 400 minus 16 times 1 squared is 16 over 4, which this simplifies out to be 96 feet per second. So the question says, find the average speed. The average speed is between 1 second and 5 seconds. Give everybody a chance to get that one written down first. Okay, the next one we're going to look at is using that same function. And we're going to have finding d of a plus h minus d of a all over a plus h minus a. Now that's kind of the same thing we did before, except we did the d of 5 and the d of 1. So when we plug this into our formula, the d of t is equal to 16t squared. We're going to plug in a plus h for t. So this gives me 16 a plus h squared, because that's what I'm plugging in for my input, a plus h. There's my t squared. So this is my t squared. Minus 16. Now what am I going to put inside? I'm going to put in the a, because the a is the input into t. So I have a squared all over a plus h minus a. Now here's where some people get a little confused, so we have to be careful, because this a plus h squared that's here, we're going to square first and then multiply in the 16. We're not going to multiply the 16 in and then square. So we're going to square first and then multiply the 16. So I'm going to get 16 a plus h times a plus h minus 16a squared. Now in the denominator, you can see that the a's are opposites of each other, so they automatically cancel out. And we have h. Here we have two binomials multiplied by each other, so we're going to have, that's going to be a FOIL situation. So we're going to have 16 parentheses a squared. Now outside is going to be AH and inside is going to be AH, so we've got plus 2AH and then plus H squared minus 16A squared all over H. So now we distribute the 16A squared in. The 16 goes into the A squared plus 32AH, and we're going to run out of space. So we have plus 16 H squared should be inside that parentheses, sorry. 16H squared minus 16A squared all over H. Okay, give everybody a chance to catch up to that point first. So what do you see that can cancel out now? Can you see anything? The 16A squared and the 16A squared, good. Here we have an H in terms of both of them, so we're going to take an H out. So that's going to give me 32A plus 16H all over H. And the H's are going to cancel out. And my final answer is 32A plus 16H. And what is this called again? This is called the average rate of change. Now, another thing that you can see about these problems when we're talking about them is the numerator is a subtraction and you also have a division. So we have something called a difference quotient that we're going to look at here in a minute. So everybody caught up? Okay, so we're going to find the difference quotient. Okay, difference, we're going to have f of a plus h minus f of a all over h. Okay, this is the difference quotient. Difference because it's subtract, quotient because it's divided. And the example of the function we're going to use is f of x equals 2x squared plus 3x minus 1. So we're going to take this again. This is the input, a plus h, and we're going to plug it in for x, all the x's. So the first one's going to be 2a plus h squared. That's going to be the 2x squared plus 3 times a plus h, gives me the a plus h here, minus 1. So that's my first part. But then we have minus. Now I'm going to subtract this whole f of a, so I'm going to put that in parentheses, and then I plug in a for each x. So I get 2a squared plus 3a minus 1. All over h. Now this one is just distributive property. We're distributing that minus 1 into all three things. But this one over here again is that multiplication. So we're going to have a plus h times a plus h. And this is distributive property again. So I get 3a plus 3h minus 1 would be here. Distributing this in gives me negative 2a squared minus 3a plus 1. Does everybody agree with that? Now, we're going to go ahead and see if we can take anything out. You can see that the negative 3a and the positive 3a can cancel out. You can see that the 1 and the negative 1 can cancel out. So in this step, we're going to bring down the 2, but we're going to go ahead and distribute with FOIL. So a squared plus outside and inside, and it's going to give us 2ah plus h squared on the inside of the parentheses. Still bringing down the plus 3h minus 2a squared all over, don't forget that part, h. So now to getting close to finishing it out, we're going to distribute in, and we get 2a squared plus 4ah plus 2h squared plus 3h minus 2a squared all over h. So now what do you see that can come out? Well, we look for common terms first. So this negative 2a squared and a positive 2a squared are going to cancel out. We see that there's an h in common of all of those, so we're going to distribute an h out and get 4a plus 2h plus 3 all over h. And then the h's are going to cancel out. And there would be my answer, 4a plus 2h plus 3. So I need to see your steps when you're doing these problems. So that was section 2.4, average rate of change in difference quotient. Thank you.